10-9, this is it. You have a test tomorrow. After this, I'll show you what the pre-test answers are. We'll take some questions. Systems. That's what we're doing the whole chapter of inequalities. This is totally a review section. Systems of inequalities. Let's go ahead and make sure we understand a few things. Shade above.
You can go ahead.
Whoops. Above and below. So what you have to have to shade above and below, greater than means you shade above, less than you shade below. But y must be alone on one side of your inequality, on the left side. On the left side. Otherwise, you're going to have to pick a point and see if it satisfies the inequality. Pick a point on each side of your line. Okay, now we're going to do dotted versus solid. So this is still all review. So dotted is less than, it's also greater than. Solid is and less than or equal to, greater than or equal to. So solid has equal signs with them. Dotted does not. This should all look familiar, right? Okay, there isn't anything new here. Okay, I'm not going to give you anything more than a parabola. Mostly they'll be straight lines. Next chapter we're going to do ellipses, hyperbolas, and circles. Okay. All right, so let's do some examples. Make sure we have this down. I'm going to do one problem here. Okay. I think this is the one on your pre-test. So let's do this. If it is bound, then find the vertices, meaning find where they connect. Here's your system. Well, actually, let's talk about what bound means before we start. So here's an example of something that's bound. If you have a parabola and there's a line that goes through it, the parabola, you're shading above the parabola, that means all of this, and all the way up. And the line, you're shading down, that means all of this. There's the double shading. That's bound, meaning it doesn't keep going on. The shading doesn't keep going. So this is an example of bound. Not bound, an example of not bound. Let's say I had another parabola, and we're shading on the outside of this. There's nothing, it just keeps on going. So that's not bound. Yes?
What if it's above, like on the bound one,
Yeah.
the line that you have, what if it's above the line, but it's still on the inside of the parabola?
Okay, so if this was saying that,
No,
you're shading above the line.
like inside the parabola.
Yes, I know.
So
But
like
it
if the
does
line
matter
goes away.
what the line is doing. You gotta look for the double shading. So if the parabola is inside, that means above the parabola, right? That would be inside the parabola if it's above, right? Okay, if the line is also above, then it would be this right here, and it would not be bound because it just keeps going.
Yeah, that's what I was asking.
Yes. Okay, awesome. All right, let's take a look. Everybody, how do we graph this problem?
Solve for one.
Solve for what?
Solve for a variable.
Solve for
Y.
y.
On the left.
Why do you do that?
Because it says to.
Y by itself.
Get y by itself because it's a slope-intercept form that you want.
Just said that.
You want slope-intercept form. How do you know if it's a parabola or a straight line?
What do you ask?
Your exponents. How do you know if it's a straight line or if it's a parabola?
If the first one's squared, then it's a parabola.
It's all has everything to do with your highest exponent. If your highest exponent's a 1, it's linear. If your highest exponent's a 2, it's parabola. So highest exponent's a 1. So put it in slope-intercept form, please. And graph it. graph 4 inequalities on this graph. This goes through the y-axis at 6, goes down 4 and over 3. It is a solid line because it has an equal sign with it. It is shaded below. You can only say if it's shaded above or below if you have y by itself. So this is shaded below. Now, this is how you should do this. So just my advice. Just put arrows to start with. Don't start shading yet, because it's going to get real sloppy with more than 2 equations. More than 2 inequalities. Here's the next inequality. This is part of your systems. 2x plus y is less than or equal to 8. Is that a linear inequality or a parabolic inequality?
Linear.
Linear, please graph it.
Wait, on the same graph?
Yep. And just draw arrows for your shading. What happens if you multiply or divide by a negative?
This one is direction.
Yeah, your inequality changes directions. We haven't done that, I'm just making sure you know that. Now the other 2 inequalities in this system would be this. X is greater than or equal to 0. What does that look like? A straight line. What variable's showing? That's the axis it goes through. The vertical line going through. 0. So it's the y-axis. It is solid because it has an equal sign. And this is the only time you can say that you shade left or right. Only with vertical lines. So we're shading left or right. It's greater than.
Right.
Sorry, I didn't know that was going to be a problem. Okay, and this inequality. Y is greater than or equal to 0. Goes through the y-axis, so it's horizontal going through 0, so that's the x-axis. And it's shaded above. So where's all the shading at? It's not a triangle.
In the bound.
Looks like a triangle, except it comes down right there. So it is bound, therefore you have to find where all the lines meet. If you can't tell where they meet, then you have to do substitution and elimination with those equations to figure out the coordinates where the lines cross each other. This example, you know exactly where it is. That's at 0, 6, 0, 0. This is 4, 0. And these two was pretty easy to see. This was 3, 2. A lot of times you can't tell that one, so you have to take those 2 lines and do substitution and elimination. That's why this is in this section. It's because you use substitution and elimination. You can use inverses and determinants to figure it out, yes.
So what's the use?
The graph and those coordinates.
Can you tell if it's like bound or okay?
Yes, but if you're giving me coordinates, it's assuming you're saying it's bound. Okay. Now, if it's not bound, we're usually looking for maximums or minimums. So if it asks for that, then yeah, you would give a coordinate for the maximum or minimum. Okay? Excellent. Now your homework, I'm going to change your homework assignment from 3 to 45 because you have a test tomorrow. I want you to do 5 problems. 37 to